So we were saying polymorphism in Java. You have already seen that one. Am I recording? Yes. Polymorphism is the ability of an object to take on many forms. The most common use of polymorphism is object-oriented program occurs when a parent class reference is used to refer a child class. We did already that one. This is parent class, child class. It is referring a child class. Now you can hear me, I guess.
Yes, we can hear you.
Okay. So this is parent, this is the child class. This is referring called polymorphism. Where do we use that one? I have two subclasses, student and faculty. By creating objects with person, superclass, I created an array with 3 elements, 3 objects. So I can say first element will be from person. Second one from student. I have name, ID. Third one faculty. I have name and something else. So these features might be many different features you might have for faculty, students, but at the end, it is just the second element in my person array. Can you imagine how easy to access them all? So I can just use a for loop. If I have a toString method, I am going to print out all the names, all the whatever information I have there. Team will come from there. Second, ID and name. Then whatever the faculty you like to print, it is going to be here again. So this toString method depends on dynamic type. It means I have a string method for each of them, and I am overriding it. So it gives us the ability to keep all of our objects in one big collection. What does get a little confusion? We have a different reference point to a different type of objects. So now we are going to have this error, compile time, runtime rules. We need to know that one. You know, when you run the Java, I believe you didn't get an error message, but I get many error message. Some of them are telling me compile error, compiling error, some of them runtime error. What are the differences? They are related to each other, and we need to know the difference, and we need to know how they are working. Think like a compiler, act like a runtime environment. So before acting, you think, you check everything one by one. After that, you act like a runtime environment. You just go to the aim. There are two pieces that happen whenever you execute code. Compiler interprets code, runtime environment executes interpreted code. Okay, compiler is going to interpret code, and runtime environment executes interpreted code. Compile time rules. Compiler only knows reference type. So in polymorphism, we have seen that we can use parent class as a reference and child as a point. So compiler only knows reference type, can only look in reference type class for method. Outputs a method signature. This is compiling. For example, here, person, parent class, it has name and 2 methods, get name to string. Student is a child class, it has student ID, get SID, and to string. So both of them has to string method. When I said person S created new method, this is the parent, this is the child, S to string. So which one is going to run, this one or this one? In compiling time. In the compiling time, this is person S. It is going to check the superclass during the compiling, not the runtime. During the compiling, it is going to check S to string. Is there a to string method here? Yes. Okay. It is returning string, yes. It's going to check only that one. String to string, it is returning the string. Method signature is string, that's fine. Runtime rules follow exact run type of object to find method. Must match compile time method signature to appropriate method in actual objects class. What does it mean? Now I created this class, person as new student, as string, string to string. So this part, during the runtime, it is going to check if I have this method in this object, in this class. During the compiling time, it is checking if I have this method in this object, in this class. So it is going to return a string. So it will come and check during the runtime, execute that runtime, it's going to check this one, if it is there or not. So compiling and running, they are checking different things. Must match compile time method signature to appropriate method in actual objects class. Here, for example, person, we created this reference object, student object, it's going to be called S, and it is looking get SIID. When you run the compiler, it's going to check, do I have this get SIID in person reference? It doesn't care this part yet. During the compiling, it is checking the reference here. Do I have this method here? No. Then you are going to get compile time error. Okay? This is the second thing I am going to mess with you during the quiz. I have many nice things to decrease your average, so be careful. But I want to check this one. If I have this method during the compiling time, if I have this method in the student, so you can cast it. Cast is a lifesaver, it's like aspirin. Cast students as now it is checking during the compiler time if I have this method here in the child class. What's happening? Runtime check. It's checking this one. S instance of student only executes if S is a student at runtime. So behind this checks, this condition is running. Example 1. I have animals, pig, dog. Animal is the parent class. I have pigs extends animal, then dog extends animal. For the main parent class, I have animal sound method, same method I have in the pig and the dog, animal sound. They are all same method, same name. Only what is difference? The message they are printing out. Animal class, it is printing, the animal makes sounds. The pig says wee wee, the dog says bow bow. So only the message is different, the rest are same. Now, I create this one, animal, my animal, new animal. So this is the reference and the class, they are all from the same. Create an animal object. Here I use the reference animal, but I create a pig object. I use reference animal, I create a dog object. Then I run the method, my animal.animal sound. Which one is going to run? My pig.animal sound, my dog.animal sound. Am I going to get a compiler error, compile time error here? Now I check my animal. It is looking this one, my animal sound. Do I have this method? Yes, because compiler is checking the reference here. This reference, does it have this method? Yes, it has this method. Second one, yes, it has. Even for the third one, my dog, this is the reference. Do I have this method? Yes. So I won't have any compile time error. It's just gonna print out. Then first the animal makes sounds. Then second, the pig says wee wee, the dog says bow bow. Nothing unusual here. What about now? Now I don't have this one. I don't have this method in the main class. And I like to use polymorphism. I use polymorphism and I create pig object by animal reference with the parent reference. Dog object with the parent reference again. Why? Because I want to collect them later on and use it. If you have this kind of fantasies, you have to be careful the methods how we are using, if they are exist in the parent class or not. So when I run that one, my animal sound. What happens? Do I have this reference animal? Do I have this method? No. You are gonna get this error. This nice red error. Unresolved compilation error. What about now? I have this method, but this child class doesn't have. And I am running same thing again. Am I gonna get any error here? I can see the chat, guys. You can write there. When I create this, okay, my animal, new animal, and my animal sound, it is going to print out the animal makes a sound. Now here, my pic.animal sound. I don't have this method here. My dog.animal sound, I have this method here. So I shouldn't have any problem here. Only changes here. Anybody else? Any comment? If there isn't sub, it will go to main. Okay. So it will go to main. Yes. So if you are extending superclass and you are running a method which is not in the child class, it will check the superclass. Why should I write all the methods here? If I'm going to write all the methods here, why do I need to extend from superclass? There are some methods there. I don't want to write them again. I will just call them and run them. Why? Because I am extending. I am telling that, okay, you are my superior. So this is you are supposed to have these methods. Okay, so you don't need to have all the methods here in the child. If you have the method in the parent, you are going to run that one. But what does Java do? First, it checks this animal sound here. Do I have this method here? No. But I am extending animal. Now it will go and check the superclass. Do I have this method here? Yes, then run it. So if it runs, first it is going to print out the animal makes sounds. I don't have the method here. It will go back here, then print again animal makes sounds. Then come back here and print out the dog says blah blah. Did you understand the trick here? Okay. Checkpoint. I destroyed many students with this question, guys. Person you new undergrads. Then I am running this one, u.method1. So person undergrad, there's a polymorphism here. Person the superclass, students, person, undergrad, students. So undergrad is extending student, student extending person. So this is the reference u, and it is running method 1. Am I gonna get compile error? No, because I have this method already here. No problem. So when I run this u method 1, this is an undergrad object. U method 1. I don't have method 1 here. I have just methods here, nothing else. So I don't have method 1 here, but it is extending student. So I will go and check student here. Method 1. Then I will print student 1. Then I will come super.method 1. Super, where is super? Person. Person is a super. Super of what? Person. Static binding. Statically we bind person. So it comes here, method 1. it is going to run. What does it do? It prints person 1. So we were here, so we will come back here again. Method 2. So what method 2 this one? Which one? This method 2, this method 2, or this method 2? Because I didn't specify anything here. We are normally student. No. We are during the compiling, we are still here. Be careful. One of our leg is still here, the other leg is moving around. So at then one of your leg is here. You didn't step out. You are inside here. You are just moving around with your other leg. So this method 1, it is dynamically type of the object at runtime. It is dynamically binding the student. So it is going to run this one, method 2. We are putting here this. You remember that this is referring this object, this class yet. So this U, it is referring that U. What is that U? That U is from undergrad. So implicitly we have here this. All the this here belongs to you for now. If you didn't specify explicitly. Here we specify explicitly. I say super.method. Where is super for this one? Here. Since I didn't specify explicitly, implicitly it is going to be here, this. This will be here. And that this is referring your object. This is you. That you belongs to undergrad. Okay? Which method? To object this type of the object at runtime, dynamic binding we have here, it is referring method 2. And it is going to print out grad 2. Okay, it's like a puzzle, but there are these 3 rows. Does anyone pass in your class with this many tricks? My average was high, don't worry. At the end, I am very merciful. So different between super method and this method. Super method get bound at compile time. This method get bound at runtime. So Java is going to use the actual type of the object at runtime, actual type of the method. If you didn't put this, it is going to be there implicitly. And during runtime, it is going to refer the objects of that class you have created. At last. Yes. Now, guys, there is one